Good morning, everyone. In this presentation, I will present a part of my work entitled about the machine dynamic modeling and simulation of a cogeneration unit operating with renewable energy. In view of population growth, lifestyle, and climate change, and to meet today's energy challenges, the world has notably made three goals to be achieved by 2050, which are to reduce greenhouse gas emissions, increase the part of renewable energy in the energy mix, and reduce energy consumption by improving energy efficiency. The use of biogas as an alternative contributes directly to satisfying this commitment. Indeed, biogas from the methanization of organic waste is mainly composed of methane and is therefore an interesting energy source since, on the one hand, it comes from a renewable source and, on the other hand, its recovery ensures a reduction in greenhouse emissions. Its use therefore has a double environmental advantage. In the current context of sustainable development research, the biogas cogeneration has great potential to replace fossil fuels used in many areas of energy consumption. Thus, the interest of cogeneration lies in the higher energy yield obtained compared to equivalent separate production of electricity and heat. It also makes a good contribution against global warming by reducing greenhouse, and the cogeneration system to be studied in this work uses an internal combustion engine connected to a synchronous generator that supplies a local load. In order to better meet the defined objective, the studies and modeling of the system are organized into four main points. An extensive definition of the general concept related to the production system, the dynamic modeling of an internal combustion engine and its speed regulator, the modeling of a synchronous machine with permanent magnet and its voltage regulator, and finally the simulation of the model under the MATLAB Simulink environment. A cogeneration unit consists mainly of combustion engine driving a cogenerator, generally of the synchronous type. We develop models of the subsystems, which are the combustion engine and its speed regulator, and the synchronous generator and its voltage regulator. These two compounds will then be coupled using the mechanical equation and electromagnetic torque of the synchronous generator. The internal combustion engine converts the energy from the combustion of the air-fuel mixture into mechanical energy. The air is composed mainly of nitrogen to which oxygen is added. A combustion engine must operate at constant speed and variable torque. The electromagnetic torque results from the connection of an electrical load to the synchronous generator and opposes the movement of the rotating mass. The synchronous generator consists of a rotor carrying a DC winding for it to move inside a fixed part carrying stator. When the direct current applied to the rotor produces a magnetic field throughout the stator winding depending on the position of the rotor. Thus, the movement of the rotor induces stator voltage, which are indeed to supply the electrical load connected to the generator. The model is applied to MATLAB Simulink. A series of simulation is carried out to study the behavior of the model. Simulation parameterization rated output power of synchronous generation is 10 kW. In this study, we discussed the modeling of a cogeneration system. The studied system implements a set of very different equipment intended to cohabit in a cogeneration structure supplying an isolated load. In order to better understand the nature of the interaction between the different subsystems of the system, an approach to study the dynamic of each system was adopted. The analysis of the combustion engine and the synchronous generator were carried out from both mechanical and electrical point of view. The results made it possible to build models of these different systems in order to analyze their performance by numerical simulation using MATLAB Simulink software.